Hey guys, so I'm gonna do a build video on one of these circuits here, the dual pole one. Should have most of the parts here. There'll be a few other things I gotta grab, but this will be a long video. I'm gonna try to get some of it done here tonight. I just have some royalty-free music there playing in the background. Hopefully, it's not too bad. Should be decently in focus, hopefully. Just want to at least get these timer parts of the circuit done tonight. Kind of tired, but I'd like to try to get these ones done. Waiting for a batch of 50k pots. I have some here. This one's brand new, but I think this one's been used. Looks like it has been soldered on. I have some more, but I have another brand new one like this, but I want to keep them the same if I'm going to use them. So, I'll get started on this anyway. A lot of tedious work doing these circuits. They're pretty similar to the single pole circuits, just a couple differences. Nothing too big. I still haven't drawn it out. This is the single pole one. They're pretty much the same except for you got a Schottky diode that is right here in the circuit, on each circuit. And then like you have another one of these side by side. And the positive from the second one goes to the negative here. You know, and then your diodes are after that. Separate. I'm using some 5408s on the output. I like these, they work really good. This circuit I want to put some 100 amp 500 volt FETs on there. I'm waiting for them to come in. I could steal some off with some other circuits, but for now I'm just going to use the NZ or Z44N. I don't know what type of music it's going to play here. It should have just put it on. Something in the background. Well, it kind of seems to have the same rhythm. Just can't see that there. pretty happy with the way this circuit works. Tested out a few PNP FETs recently. They might work. I could build this circuit with a bootstrap on the high side, but I don't like the way the bootstrap works because of the way it acts when you're trying to run things full speed and stuff like that. It needs to be pulsed, that type of a circuit. Like I do like to pulse my circuits, but not always. I tend on using these circuits to use this thing. A long time ago, I had one of these type of motors with a commutator. Same thing, but with a commutator. And it was hooked to my wood stove, and it pumped water continuously and charged a second bank of batteries. That one had a rotor made from a 55-gallon metal drum. The outer ring of it. That thing ran for years. It had shitty ceramic magnets in it that eventually demagnetized. It just got worse and worse as time went on. I know I've made quite a few smaller ones just to run fans and stuff. I had a levitating Newman motor. Let's put this on now. And it had a ramp built into it. I actually still have that one. It's in one of my old vehicles there in storage. I ended up dropping it and bending the shaft. But that one had a fan on it. It ran continuously all the time. Ran on AA batteries. That one had a mechanical switch. Took like a normal relay. Like it ran on such low input voltage, but it gave a really high output voltage. And had a mechanical relay with a tiny little magnet. If I have time, I'll grab that rotor. They were like really small little N52s. Like, I mean, really thin. And about half the diameter of one of these. Just tiny little things. And you were able to take apart like a relay, mechanical relay. Kind of a real small one like this. This one's broken, but you know how they come up with their contactors right here? And they just put that magnet on the relay. That one ran for years too. And I had like a little screw that you could just screw with your hand with a little, like they're pointy, right? So, and it was brass, the screw, brass or copper. So I could adjust the timing with that by making the gap thinner or wider. That one did some really interesting stuff, that motor. Went fast. That thing went fast. Screwed that up bad. Too tired to be in here. It's not gonna make it easy. Just go get some. Oh, worry about it later. Wait a second. Some wicked Floxy guys should support this guy if you're ever doing a lot of soldering or BGA work. Black Horse repairs. Best flux I've ever used. This last batch of his is really good. It's natural, like it smells like pine trees. I do quite a bit of CPU, like socket replacements and motherboards. I don't show that stuff, it's pretty boring. I have a homemade BGA machine, works amazing. Infrared heaters. I tend to forget stuff really easily, so I don't know why, but it's just so much stuff on my mind. Too many things on the go. Screwed down, I've been not getting that flux out of here completely. See, I knew I screwed up when I got that solder messed around here too much. Made a blob of it. Should work now. Sometimes it's better just to sleep, but I don't have much time. I want to get this one built by tomorrow night. Got a big motor build coming. I don't know if I'll get it done this year or not, but I'm kind of waiting on that one for a couple more. I haven't enough magnets. I could use my wind turbine magnets, but I want to get some that are wider for that. 3-inch. They're not cheap these days, that's for sure. Sure happy I bought all those wind turbine magnets when I did. The motor that I'm building, though, it's not going to be cheap. It costs a shitload of money. It's not going to be easy to move either. It's going to be really heavy duty. Like just these bearings here. I remember when I bought these, it took forever. They were like, I think they're over a year and a half before I got them. And these are expensive, man. Insane price. I can't remember exactly what they are, but they cost a shitload of money for those bearings. For that. I got lots of the normal ones if I need them, but I'd rather use ceramic bearings for this stuff. Pretty sure I have some of the normal ones. Yeah, I got some of them too. I'd rather use the ceramics. For this stuff, my wind turbines, I always use tapered. The way this works, it just works really good the way shorting lines up on these little boards for this circuit. Checking which way to put them in. Which direction? Pretty sure they go here. See, these are dual here. I'm just going to use the back one. 404, 1N407s. You have to make sure you only connect to one of these if you're using a dual pot like this. Otherwise, you'll half your resistance. Maybe a 25K pot instead of a 50. That's about the most time consuming parts is this part right here. Like on the circuit. After I get these rheostats tied in, it usually goes pretty quick. The other parts kind of all fall together, and there's just a couple little bridges to make with the wire here. This wire is time consuming. Perfect little wire for this though. Phone line wire. Oh, little tweezers. Just like to look at it and make sure my connections are good. Regulators. So I've already got the spots marked out for these. By putting this regulator with its legs a certain way, with the capacitor in a certain way, it makes it a lot easier. The ground goes here, and then I think there's another jumper from ground to over here. Pin 8, I think it is. And then this lead goes here to pin 4, I think that is. And if I put my cap in just right, these longer leads here help to make those connections. See, I can catch the voltage regulator right here, and then to this right here. That's where it needs to go. Looking for resonance on here. It's short. I think there's one more from here to there, and I think this one is done. And after I get this one done, I'm just going to stop the camera and finish this one, and then we'll test them both on camera. Just hook the scope up to them, make sure these ones work, make sure everything works before I go to the next stages. That's how I always do it, and sometimes I find out they're not working. better to find out now rather than build the whole circuit. But there's hardly really anything. If there's something that's wrong with the circuit, it's pretty easy to figure it out. Unless you got a broken wire or something. Or if I forgot something, do that too sometimes. I don't build these ones too often anymore, but probably building a few of them now because these driver circuits, like, I just hope those PNPs are gonna work out good. They're supposed to have some decent resistances when they're on and stuff, so we'll see if they can. If they're not going to give over Unity results, it's no use even using them because, you know, building this to make this circuit that works, not one that functions but doesn't give good results. The PNPs just don't have the capabilities that NPNs do. They just don't switch the same. I forget most of the stuff I was ever taught. When I go back to work, I forget what I was doing. Forget how to load the excavator and stuff like that. It's just like, holy shit. How much stuff on my mind. Forget how to work the whole bit. Forget directions do a lot. I've always been like that though. Not getting worse. Just always been that way. Always doing 100 different things all the time. This is one I should actually just have solid, just soldered in there. Instead of screwing with that all the time. Put these first or anything else here. Like power inputs and get one of these connected to the signal. Every time I use the damn tweezer, it goes flying. Been handy. So I just keep these little pieces. They come in handy for this. So there's a signal. Keep these little pieces around. Come in handy. Stuff like this. Positive in is this one. So it'll be that. That's it. It's an hour here, so not bad. Almost did two of them in an hour, so just have to do the voltage regulator on this one, but you've already seen that, so I'll be back when we're going to test it. Okay, got them all finished here now, a few minutes later. So I forgot to put this jumper on, I noticed. So those are on now. As far as I can remember, it looks complete. Just going to hook it up quickly here. I got a 12-volt battery here. Hopefully everything's put in there properly. My scope right here quickly. So this is the signal out, common ground. Positive is right here. Input to the voltage regulator, 12 volts in. And this needs to be changed to DC. Oops. Okay, here, let's see. Turn the power off so you guys can see. So just turn it off, it's all hooked up to it. The top one is the one I'm using. And there we go, it's on. 2 kilohertz, you can see in the bottom left there. So I'm changing the frequency right now. I'm bringing the frequency down. And I can keep the duty cycle the same despite lowering the other pot. But I can bring the this frequency and the duty cycle. I can change them both with this circuit. This is why I like it. So you can keep the duty cycle the same. Or I can bring it way up. and bring the frequency back up. I think there's what? How much of a variance here do we have? From 2K down to 1.4, which is a pretty decent, a little bit of a spread to work with. And there's a duty cycle. Real nice ons. That's pretty much all the way on. This is almost all the way off. So now it's working. Hook up the second one. If that one had the used pot, it's working. We know where the way is. Hopefully they both work right off the bat. Here goes. I don't know where the pots are set at, but I'll put the power on here now. Set it. Oh, I don't see any action. So it's not doing anything. So I'm just going to troubleshoot it and I'll be back. Okay, that was quick. Should have just took a look at the back before I turn the camera off. It's right here. I didn't connect the signal to the IC. So I'm just going to solder that quickly here and should be going hopefully. This is what you go to do. This is why I like to test this stuff before you turn it on. It wasn't connected to the signal. See if that helps. Should be hooked up here now, so hook the power. There you go. Perfect. Make sure this 50K pot's working. And we're getting around the same frequencies. Point 2. 1.49, and then a duty cycle. Looks good. Should be good. Looks like a good one.